All right, today we are cracking open the Modern Data Scientist Toolkit. We're going to go on a journey, starting from this chaotic sea of raw data and ending up with clear, powerful insights. And along the way, we'll see the exact tools that make this incredible transformation possible.
Take a look at this. It's just a jumble of letters, right? Seems totally random, but you know that with the right rules, they come together to form a word, to create meaning. Well, that is exactly what a data scientist does. They take all this raw, scattered information and turn it into a coherent story. It's really a modern form of exploration, and just like any great explorer, you've got to have the right set of tools.
So here's our roadmap for the day. We'll start at the very beginning, where we store our data. Then we'll learn the language to talk to it, which is Python, and get our hands on the single most important tool for shaping it, Pandas. After that, the fun really begins as we uncover secrets with machine learning. And finally, we'll take a peek into the future by teaching computers how to understand language.
Every data journey has to start somewhere. And for us, that's a database. You can think of it as a digital vault, a safe and organized place where we keep all of our raw materials, our data, before we even think about starting our work. You know, it's kind of like a library. Before you can write a big research paper, you need a place where all your books and sources are stored in a systematic way. A database, like MySQL, is that library for our data. It gives it a structured, secure, and efficient home so nothing gets lost or messed up. It's the absolute bedrock of the whole process. Now, I get it. Setting up a database can look super intimidating. You might see a huge log file just full of technical commands and think, no way. But what's so cool is how you can boil it all down. At its heart, the process is really just 4 key steps. First, you write the rules. Then, you open the right doors in the firewall. After that, you build the empty shelves by initializing the database. And finally, you just flip the switch and start the server. See? Much simpler when you look at it that way.
Okay, so our data is sitting safely in its vault. But how do we talk to it? How do we ask it questions and get answers? For that, we need a universal translator, a lingua franca. And in the world of data science, that language is, without a doubt, Python.
And this really shows you why. Python is not a one-trick pony. It's an absolute powerhouse. People use it for everything from building websites to running complex math. But its real claim to fame is its common-sense syntax. It's just easy to read and write, which means data scientists can focus on solving the actual problem, not fighting with the code.
So let's do a quick lightning round of Python's basic building blocks. First up, you've got integers. Super simple. These are just your plain old whole numbers, perfect for counting things.
Then there are strings. Anytime you're working with text, like a person's name, a customer review, anything like that, it's going to be a string. It's just a sequence of characters, inside of quotes.
What if you need to hold a bunch of different things all at once? Well, that's what a list is for. It's an ordered collection where you can just toss in numbers, strings, whatever you want, and they'll all stay in the exact order you put them in.
And finally, we have the incredibly useful dictionary. Now, instead of relying on order, a dictionary uses labels, or what we call keys. So you can just ask for the name and get Alice, or ask for the age and get 25. This is absolutely essential for keeping labeled data organized. Okay, with our Python basics down, we can now grab the most important tool on our workbench, a library called Pandas. Seriously, if Python is the language we speak, Pandas is the Swiss Army knife that lets us take raw, messy data and just wrestle it into shape.
And this is the heart and soul of Pandas. It's called a data frame. I know, it just looks like a spreadsheet, but that's the whole point. It's designed to feel familiar and intuitive, but trust me, this simple table is supercharged with an unbelievable amount of power. Pretty much everything you do to manipulate data in Python happens right here.
And I really do mean supercharged. For instance, imagine you have a massive file of messy customer data. With just one command, drop NA, you can instantly get rid of all the rows with missing info. With another, group by, you can figure out what your average customer rating is for each product. That's the key. It turns a mountain of messy data into sharp, actionable intelligence.
So, let's recap. Our data is stored, we can speak its language, and we've cleaned it all up on our workbench. Now it's time for the really exciting part, the revelation. This is where we use statistics and machine learning to finally make our data talk and tell us its hidden secrets.
Let's make this real. Let's say Professor Wong is running her classes in 3 different formats, and she wants to know, for real, if one of them is actually more effective than the others.
How can we get a real answer? We don't want to guess, we want to let the data decide.
And here is our data-driven answer. We run a statistical test, and it gives us this one little number called a p-value. The easiest way to think about a p-value is as a surprise meter. If it's a tiny number, usually less than 0.05, it's the data screaming, "Whoa, this is surprising. Something significant is happening." But our value here is 0.29. That's not surprising at all. It's the data's way of telling us loud and clear, nope, nothing to see here. All three class types perform about the same.
But finding out there's no difference is just one type of insight. With machine learning, we can go a huge step further and actually start predicting the future. On the left, you see a simple model that's great at predicting a yes or no answer, like will this customer subscribe? On the right, a much more complex neural network that can learn really intricate patterns to make decisions. Now, these models usually fall into one of two camps. There's regression, which is all about predicting a specific number, like how much will our sales be next month. Then there's classification, which is about predicting a category, like is this email spam or not spam? Choosing the right one all comes down to the kind of question you're asking. We have covered a ton of ground, but there's one last stop on our tour. We're heading to the frontier of data science, natural language processing, or NLP. And what is that? Well, in short, it's all about teaching computers how to read and understand human language.
So how does that even work? I mean, take a look at this movie review. It's just a block of text. It's full of opinions, feelings. It's unstructured. How could a computer possibly make sense of this? How could it figure out the vibe of the review?
Well, the process is actually surprisingly logical. First, you tokenize the text, which is a fancy way of saying you chop it up into a list of individual words. Next, you remove all the stop words, common filler words like the, and, that don't add a lot of meaning. Then you stem words to their root, so animators just becomes anim. And once you've done all that, you can finally count which important words show up the most.
And check out the result. After that whole process, the words that pop up the most are movie, disappointed, and really. Instantly, without even having to read the whole review, you get a really powerful signal about what it's about and how the person felt. That, right there, is the power of NLP. So there you have it, the whole toolkit. We started with the database foundation, learned the language of Python, used the workbench of pandas, uncovered revelations with machine learning, and even explored the frontier of NLP. You've now seen how a data scientist turns total chaos into crystal clarity. So the only question left is, what problem are you going to solve first?